In the lecture, I show this equation where z equals x minus mu over sigma. And in the slide, I also have a problem. But first, I'm going to go through this equation a little more closely so everyone understands. So z is the z-score. We have x, which is the raw score. And then mu, which is mean. And sigma, which is standard deviation. So in the problem, where Juan receives, it says a description of the mean within the statistics class as well as the standard deviation of that population, and then what Juan received on his exam. And then in his psychology class, there's a mean for the exam of 84, and then the standard deviation for that population is 6, and he received a 93. So the question is, which class did Juan do the best in compared to the rest of the class? And the way that you would do that is converting this raw score into into z-score, right? Because your z-score is in standard deviation units, and so you can tell how well you can compare what Juan did within these two classes. You can't compare it based on the raw score, you have to convert that to z-score because the mean, as you can see, is different between the two populations as well as the size of the standard deviation. Does that make sense? So I'm going to calculate the z-score first. So whenever I see a word problem like that, I write down what is known. So every single time I see a word problem, I write down everything that I know and what I have to find. So I guess for this question, I should have said z-score is what's z? Because I want to see which class did Juan do better, right? Compared to the distribution. Okay, so with this equation, so I'm going to do statistics first. We have the raw score of 86. I'm just plugging the numbers straight into this equation. So the raw score x is 86 minus the mean, which is 76, all over standard deviation, which is 5. And so when I subtract 86 minus 76, it's 10 over 5, and so the z-score for statistics is 2. I had to do the same thing for psychology. So all I'm doing is taking these numbers and plugging into the equation. So the z-score, and then the x, right, is 93, minus the mean, which is 84, all over standard deviation, which is 6, okay? And when I do 93 minus 84, that's 9, all over 6, so that is 1 point. This is why we have a calculator. Oh, sorry, wait, 90? Wait, what am I doing? 9 divided by 6? 1.5. So that's the z-score. So now we know that in Juan's statistics class, he had a z-score of 2, and so that means he was 2 standard deviations above the mean, right? For his z-score of 1.5, that means he was 1.5 standard deviations above the mean. So the class that Juan did better in was actually his statistics class.